Hi, my name is Travis Ham. This is the final Intro to Chem online class, lecture with lab. My hypothesis is that I can create battery power using nothing but a potato, battery power from a potato. The research I conducted before I decided to make this battery basically was just searching on Google, searching several different sites. I found that most of the sites are actually kid-oriented. If you'll look at the references right here, zoom in here. Most of them were kid-oriented, which explain how to conduct the experiment, but didn't really explain how it worked and the mechanics of it. So we have kidsworld.com, WikiHow. Those two were more about how to create the battery. This last one, this howstuffworks.com, that went into more of the mechanics of how the battery actually worked. So now that we have the references there, I use those three sites mostly for my research. The materials needed to create a potato battery are 2 potatoes, 2 galvanized nails, pretty standard nails that you can get anywhere in any hardware store, 2 copper nails right here, some alligator clips. For this actual battery, you just need 3, but you can buy these at Radio Shack. I got several in a pack here. You're going to need an LED that is 1 to 2 volts. Anything more than that probably won't work. This battery's not going to be producing as much as it'd be similar to what a watch battery would produce. One thing that we are going to use that you don't have to have, but is a electrical voltmeter, so we're going to use that to kind of see how much is actually being put out. So, how this works is a potato is an electrical chemical battery, otherwise known as an electrical chemical cell. An electrical chemical cell is a cell in which chemical energy is converted into electrical energy by a spontaneous electron transfer. Some batteries, actually now that we have, use galvanized cells to transfer chemical energy into electrical energy. They depend on 2 metals, a cathode or a positive terminal, such as the copper nail, and a negative or an anode negative terminal, such as the zinc or the galvanized nail in this lab. These 2 types of metals are placed in electrically conductive solution in a battery. They usually use an acid like sulfuric acid. So how this works with the potato is the potato actually has an acid in it as well. It's phosphoric acid, which works to help create that conduction as well. The acid steadily eats away at the zinc, or the galvanized nail. A chemical reaction takes place which releases zinc electrons, spare zinc electrons. These electrons then join with spare hydrogen ions in the acid to create a hydrogen gas. Meanwhile, the copper nail isn't really doing anything until you connect it directly to the zinc using, the thin conductive alligator clip. The spare zinc electrons are still intent on forming like hydrogen gas, but they have an easier time of doing it with the hydrogen surrounding the zinc anode. So the electrons from the copper cathode travel through the wire to get to the zinc, and basically the battery just exploits this flow of electrons, allowing us to use the electricity that it produces, combined electricity. So, to sum this up, the zinc in the nail reacts with the copper in the other nail, the copper nail. The potato acts as a sort of buffer in a way that the zinc and the copper ions can kind of exchange over that phosphoric acid, the acid inside the potato. Since the potato keeps the two apart, the electron transfer has to take place over the copper wires of the circuit, which allows us to channel this energy into the LED or the voltmeter. So, if you'll zoom in here, to put this together, you're going to need copper and galvanized nail in each end of the potato here. You're going to need the same on the other end. You're going to need one wire that's going to be connecting the copper ion to the zinc ion. Then you will use the alligator clip that connects the copper wire. This will be your positive terminal, which would go to the positive side of the LED or the voltmeter. And then so the positive will connect to the copper, and the negative terminal will connect to the galvanized nail, the zinc. Okay. So this is basically the schematic of how this electric current takes place. In the potato, it's actually, there's a current crossing between the end of this nail and the beginning of this copper nail. So we turn on our voltmeter here. You can see that right now we are at 0 volts. Nothing there. Looks like these are probably touching right now. We connect to test. And currently we're producing, zoom in right there, about 1.4 volts in DC. And one thing I do want to point out before I attach the LED is through experimentation I found that the farther the actual connecting wires out are, the higher the actual electricity that is measured. So now it's going up to 14.5, 14.15, 14.2. So if these two, if the galvanized nail and the copper nail were actually all the way pushed together inside this potato, they would still conduct, but it would be more in heat instead of electricity. And it's the space between that allows us to use this electricity. So right now we're at 14.3, 1.43, when we're at 1.4, with the connectors a little bit more farther in. So we'll go ahead and connect the LED, and I apologize, it is only producing 1.4 volts, so it's very dim, and I hope that the camera can pick it up. Okay, zoom in there. It's very dim. I hope the camera can pick it up. If not, we have proof that it has capable of producing minimal amount of voltage. So, what we have learned to address the hypothesis is through combination of copper and zinc or galvanized nails, the phosphoric acid inside the potato, we're able to produce electrical current. We're actually able to produce a battery. Cannot power much with it, but I count this as a successful lab. That's it.